Welcome to Eyewitness Virtual Reality EarthQuest. Ahead of you, in the Earth Gallery, is the Earth Builder, an interactive 3D tectonic plate challenge. Answer the Earth Builder questions correctly to rebuild the Earth's outer shell, then unlock the secrets of its past.
Red sandstone. Micaceous sandstone. Blue marble. Green slate. Chondrite. Obsidian. Lithic tuff. Malachite. Azurite. Apatite. Turquoise. Actinolite. Aquamarine. Heliodor. Barite. 5 billion years ago, the Earth did not exist. The solar system was just a cloud of dust and gas on the edge of a huge galaxy. As this cloud contracted over time, much of its gas and heat became concentrated at the center. A flattened disk of dust rotated around the mass of dense gas. Dust collided and stuck together to form rocky chunks. The large rock fragments grew fastest as they swept up the dust in their path. The infant sun suddenly flared up, creating a solar wind that swept away the gas and dust. The bodies that remained were the planets, moons, and asteroids of the solar system. Secrets of the Earth's past are contained in its rocks. Exposed layers of rock help geologists piece together the history of the Earth. The sediments that make up sedimentary rock accumulate in layers. As each layer is deposited, it buries an earlier layer. Thus, the deepest layer in a stack is the oldest rock. The overlying layers consist of younger rock. To find out a rock's age, geologists study any fossils it contains. For example, this type of ammonite was common about 200 million years ago, so the rock must have formed at that time. In this way, fossils give vital information about the Earth's past.
Constant battering by waves gives many coastlines a jagged, irregular shape. A coast can consist of many different types of rock, some of which are more resistant to erosion than others. Bays are sculpted from softer rock as waves curve around a headland. Pillars of rock that rise out of the sea are remnants of a past shoreline before the coastline moved inland.
Yellow sapphire. Sapphire. Halite. Diamond. Gold. Graphite. Cinnabar. Galena.
This machine is drilling blast holes. The next step is to charge up by loading explosives into the holes. Then, once people and machinery have been cleared from the blasting area, the explosives are detonated. Note how the explosives are timed to go off in sequence, which lessens the ground and air shock produced by the blast. When the dust has cleared, the exploded rock will be loaded into trucks. At Mauna Loa volcano in Hawaii, a huge fissure opens in the ground, erupting spectacular fountains of glowing lava. At Kilauea, also in Hawaii, lava bubbles more gently to the Earth's surface, filling a crater with a huge lake of lava. Its surface blackens as the lava cools. From time to time, the lake overflows, and the lava pours away in streams of glowing molten rock. Pillow lava forms when hot molten lava comes into contact with cold seawater. The surface of the lava cools and hardens into a bulbous crust, but the inside remains liquid. Each pillow spawns another as its crust cracks, and a new bulbous lobe oozes forward. Pillow lava is the most abundant volcanic rock on Earth.
Earth tremors and bulging of the mountain show that large amounts of magma are ready to erupt. A small eruption releases the pressure within the volcano, allowing the magma inside to expand violently, triggering a massive eruption. A huge cloud of ash and pulverized rock blasts skyward, covering the landscape in layers of ash, and pyroclastic flows pour down the mountainside. The volcano collapses, forming a caldera. Steam and volcanic gases erupt from a vent within the bowl of this caldera as magma rises slowly toward the Earth's surface. The magma erupts as thick, sticky lava that piles up around the vent, forming a lava dome. As the eruption continues, lumps of lava break off from the dome and tumble down its sides.
In mountainous regions, an earthquake can shake loose snow, ice, and rock from a mountain slope, triggering an avalanche. The avalanche hurtles downhill at tremendous speed, collecting more snow and rocks and trees as it travels. A town that is unlucky enough to lie in the path of an avalanche may be swept away or buried in snow. During an earthquake, gas should be turned off as quickly as possible. Fire can take hold very quickly in a kitchen and soon spread to the rest of the house. In September 1923, a huge earthquake started fires in kitchens all over the city of Tokyo. 2/3 of the city burned to the ground, and nearly 100,000 people died in the resulting inferno.
This exceptionally powerful earthquake in Bolivia originates at a very great depth. Due to its depth, it does not generate any surface waves. Its primary and secondary waves, shown in red and blue, register very clearly on seismograms at monitoring stations around the world. This very powerful earthquake in Bolivia originates more than 600 kilometers beneath the Earth's surface. Primary waves, shown in red, and secondary waves, shown in blue, spread out from the earthquake, and their shaking is felt over a very wide area. No surface waves are generated, however, due to the depth of the earthquake.
Unfortunately, this powerful earthquake is too deep and distant to cause much damage. However, everyone notices the shaking and most tall buildings sway significantly during the tremors. Most poorly built structures on loose sediments are extensively damaged by the earthquake. This powerful earthquake causes severe damage to the town. On poor ground, even well-built houses and office blocks slip from their foundations and some sink into the ground as it liquefies. The shaking distracts drivers enough to cause automobile accidents, and landslips undermine roads.
Pangaea was the supercontinent that was made up of all the world's land joined together. It existed at the beginning of the Triassic period, 250 million years ago. The northern part of this great continent is known as Laurasia, and the southern part as Gondwana. The vast continental interior was dry desert because the storms coming off the oceans dropped all their rain near the coastlines, with little moisture reaching the interior. Pangaea slowly moved northward, carried by the plates underneath the Earth's surface. It started to split as the beginnings of the Atlantic Ocean opened up between North America, Europe, and Africa. Laurasia and Gondwana were the two main areas of land at the beginning of the Jurassic period, 200 million years ago. In eastern Gondwana, the outlines of India, Australia, and Antarctica were visible. Western Gondwana comprised Africa and South America. A rift opened up between Laurasia and Gondwana as the plates underneath the area moved in opposite directions. The ocean between the two landmasses widened, causing them to separate. On the west coast, a mountain chain was forced up as two plates crunched together. Around the world, rising sea levels caused the oceans to flood into low-lying areas. At the beginning of the Cretaceous period, 140 million years ago, the outlines of Africa, India, Australia, parts of Asia, Antarctica, South America, North America, and Europe could be seen clearly. Southeast Asia moved north and merged with the large landmass that was Laurasia. Africa, India, and Australia broke away from Antarctica. Meanwhile, the very active spreading ridge on the sea floor of the forming Atlantic Ocean widened the ocean, pushing apart Africa and South America, and Europe and North America. India and Africa were carried north by plate movement. Rifts began to appear in East Africa that would eventually open up a new ocean. 20 million years ago, India collided with Asia. The impact of the collision pushed up the mountain range known as the Himalaya. Gradually, the land masses moved into their present positions.